continuing on with class 4, here is an example of doing a design. This is a problem from Norton's design of machinery. And we want to design a compound gear with exactly a gear train ratio of 180 to 1. So what we want to do, we don't know how many stages we're going to need for the 180 to 1 gear design. So let's try what happens if we take the square root of 180, right? So the idea here is like, let's break it up into 2, right? So let's try 2 stages. So each stage is 180. We end up with a 13.42. So each stage would need to be 13.42, but max is 10 to 1. So no good. Frowny face. So try 3 stages. And what would we do for that? We would cube root it. If we cube root it, we get 5.646. So possibly 3 stages. We'll see. Now, we want to try to figure out some kind of, it would be nice to have, we have to have whole numbers of teeth, right? So we have to start to get playing around with integers to try to see if we could get a 5.64 ratio, right? So like some of the limits for us is how small the pinion can be. We know that we could probably get away with 17, but let's try as low as we possibly can go. Somewhere like about 12 is about the smallest that we can get away with without interference, right? So let's try some pinions. So let's say, and this is not necessarily the technique that that is like prescribed that you have to use, but this is an example of a technique. That's my understanding from what I see. So we're going to try like 12, 13, 14, even tried 15 and 16. Tried a lot pinion teeth. And our goal here is to find what's going to be the closest integer that we're going to be able to get, right? So if we have pinion teeth right here, all right, 12, 13, 14, 15, and 16, right? And we're going to multiply that by our 5.646. I'm going to do all of those, right? So I'm not going to write it down every time. So I have enough equal signs. It's the 13. Yes, okay. If we do that, we get, so the gear teeth, the number of gear teeth that we would have for this selection right here is up to 67.75. Can't have 0.75 teeth. 73.40, can't have 0.40 teeth. 79.05, that's close to being an integer right there. 84.69, no good, and 90.34 right there. Okay, so we also, if there's 14 teeth, we might need to also check for interference with that. So we would come back into, I need to go back into my, let me see. Oops, I forgot. Okay, where were we? So this is the closest to integer. That's why I wrote that down. Closest to an integer. So we focus on here. There's also, let's see, so like if we did 3 stages that were 14 to 79, right? So if we were to use that, that would be the same thing, by the way, as writing 14, 14, 14, 79, 79, 79, right? If we so if there was if three stages, so if three stages of 14 and 79, not necessarily do we write it that way right there, I just happen to write it right there, we would end up with 179.68 to 1, which is 0.2% off from the goal of being 180 to 1, right? So maybe, because they set a specification, someone who sent us on a mission, and they said you have to be 181. Were they really serious? Is 0.2%? Is it going to matter? Well, it depends on what your relationship is with the people who are writing this thing up there. If it's a taskmaster, they don't want to come back and said, I said 180. Okay, well, all right. But it's also maybe if it's an exercise, we want to get 180. So, so try separating out. So that this was like just informational. For your informational an idea. Maybe the right way, a better way than just to take the cube root of the thing and then try to find integers and then try to find a good, is to break this thing down into the 180. So let's break 180 into integers. Integer multiples. And there's a math thing. Maybe one of you watching this video could contact me and remind me what the name it was. We were trying to not common denominators, but we were trying to break the thing into, there's a name for this. Can't remember what it is. But anyway, let's see. Let's divide it by 5, right? So 180 divided by 5 is equal to 36. Therefore, 5 by 6 by 6. So let's take a stage that's 1 to 5, and a stage that's 1 to 6, and a stage that's 1 to 6, right? So that might work. So therefore, we would get 5 to, 5 to 1, 6 to 1, and 6 to 1. We might even want to mix it up and go 6 to 1, 5 to 1, 6 to 1. That's the thing. Maybe. So if let's say that you have, for a 5 to 1 ratio, let's say that you have a 14, so here's pinion, that would generate for the gear, so the pinion times the 5 for the gear is 70, and the 6 to 1 for the pinion, let's say we'll pick 14 times the 6, we get 84, right? So that would be a way to do it right there. We would have so the gear teeth would be 14, 14, 14, and 70, 84, 84. And I believe what we're going to end up with is a gear train that would actually be, it's actually going to be 1 over 180, right? So that would be what the gear train value was going to be onto the thing. So if we're trying to get a 180 to 1 thing as part of this, I think the phraseology of this is we need to establish what that is a little bit better. But anyway, that's long enough right there. That's a 10-minute thing. So let's close that one down.